6 hours.
All right, we are on our final topic. We are talking about average value. I didn't say 1 day section, so this is the last section. So that means Monday, Tuesday, we will be reviewing. Test Wednesday, and then we'll go into final review from there.
Oh my gosh.
So the end is near, guys.
10 days left.
It's getting real.
Do we get final hours, I'm guessing?
No.
No.
No,
only
not
up 2
for
days.
seniors. So I'll split your final into 2 days. So it'll be the 6th or 7th and 8th.
The 7th day.
7th, 8th. Wednesday, Thursday, whatever that is.
Oh,
It's
okay.
the least amount of finals I've had. Only have 2.
Oh, wow.
All my finals for my other classes are like papers and stuff. So
So I didn't need to build in this much time for final
Oh,
review. You
good.
guys have nothing else to do. You could have just done it all then.
no.
What?
Calm down. Chill out.
Okay. So averages. In general, how do you find the average of?
Add all the things and then divide them by the number of things.
Okay, so we're used to finding averages where you add up everything, divide by the number of objects, right? If you want your average test score, you add up all your test scores, divide by the number of tests you've taken. However, if I want something with infinite values, I can't just add them all up. So think about like temperature. How do you find the average temperature in a day? You know, you could take like the average from each hour, but is that truly correct? No, it's kind of like using those areas of rectangles, right? It'll be close. Be better if we did the average every 30 minutes or the average every.
Milliseconds.
Yeah, so we could always get more accurate. So in that case, we need a different strategy. And so we know the smaller our interval, the more values we have to add up, right? And we really want the limit as that number of values is going to infinity. And when you have the limit as n goes to infinity of a sum, that is talking about an interval. The difference is we always have to divide by the number of values, right? So if I were doing my temperature every hour, I would be dividing by 24. If I did it every half hour, I'd be dividing by 48. What's happening to that denominator? Okay, it's getting bigger and bigger. So when we look at this, we need to figure out what we're going to divide by. Okay, if we were doing triangles, the width of a triangle, we know, change in x is ending minus beginning divided by n. So if you were solving for n, you'd multiply it over and divide. So it's the ending minus beginning divided by the change in x. So at this point, we are adding up all these x's. Right, and we know we have to add up this n number of rectangles as the number of rectangles going to infinity. And we divide by b minus a over change in x. But we said the top is really a sum from 1 to n of my f of x sub i's. And if I want
Is that divided by?
we really need this to be going to infinity, right? And so if you multiply, or if we add in our limit as n goes to infinity, then this top is turning into the integral. Bless you. How do you divide by fractions? Okay, so if I pulled out, this is 1 over b minus a, integral f of x, change in x is really the same thing as saying dx. So, ta-da, we just proved it. Average value from 2 points, starting at a, ending at b, is 1 over b minus a times the interval. So all we're going to do, if I want the average value of the curve, is we integrate it, and we have to divide by the length of the interval. And that's it. That's our average value. So the next box, I think I just put that all nice and pretty for you. So this is our explanation as to why. And then we have it all summed up there. So let's do a problem. the average value of the function f of x equals 1 plus x squared on the interval -1 to 2. So we have to integrate. And to get the average value, we need to do times 1 over b minus a, ending minus beginning. So the only thing that's different is because it's average value, I have that fraction in front. So we just have 1/3 times the integral from -1 to 2 of 1 plus x squared dx. And this is something we can integrate. What's the, let's keep the 1/3, what's the antiderivative of 1?
X.
Plus antiderivative of x squared.
1/3 x cubed.
1 to 2. Okay, so 2 cubed is 8 thirds. Minus, if I put in a -1. So then we have 1/3 times 6 over 2, which 18 divided by 9 is.
Oh, it is 2. Okay, anyway.
So confident.
I didn't think 18 could be divided by 3 for some reason. That's something I'm going to do on the test because I want to have a calculator, so I'll put 18 over 9. You'll have to take off multiplication.
Alright. Any questions about calculating the average value? So the next question is, would there be a number, c, where the function is equal to the average value?
Yeah.
Yeah, that should happen. And we've kind of seen that before in just like our velocity questions. I think we talked about like mean value theorem. Remember, and I said if you're driving to Hannibal and your average speed is 45 miles per hour, is it possible?
On the highway.
Is it possible to drive and have an average speed of 45 miles per hour without ever going 45 miles per hour? No. So we know that somewhere, and it could be multiple places, it has to be equal to. Okay, that's from the mean value theorem. So there has to be a place where my function is equal to the average value. So let's find that in here. Okay. So we just did this problem, and we know from example 1, the average value was 2. So I just want to know what's the number. The book will say like find f of c. It doesn't really matter if you call it c or not. As we want to know, when does this equal 2? So when c squared equals 1, so c is plus or minus 1. Quick check, are both of those in the interval? Yes, so they both work. Now it's possible that only one of them was, in which case you would only give me that answer. So we found on this one it had 2 times when it was actually equal to its average value. Let's look at another one. I'm actually going to skip this one. We talked about that. Okay, if I want to find the average value of this function for x in the interval 0 to 2. So, you ladies will have to watch the video and have the explanation of why. But average value, we said, is really just the interval from 0 to 2. But what else do we have to put with it?
1 over d minus a.
So you have to multiply it by 1 over the length of the interval. So we get 1/2 times the integral from 0 to 2 of x squared dx. That is our average value. So what's the antiderivative of x squared?
1/3 x cubed.
And I do need your help, don't you get 1/6 times 2 here minus 0 cubed. So 8/6 for 4 minutes.
That time I thought it was 18/6, and I was really excited that I could do that. But I was wrong.
Do you see what you did?
Yeah.
Did you think your parenthesis
I
was
thought,
a 1?
no, I just thought my 8 was an 18 in my brain.
Okay.
I didn't write anything down.
Is that one okay? Let's do a couple more. In Athens, Georgia, the mean daily temperature after July 15th is closely approximated by this equation. Find the average temperature between September 15th and December 15th. So, average we have to integrate.
I promise there is one. But it's just
I have wooden pencils. Do you want one?
Does the interval have to be something with the number 4 because there's 4? Or would it be 3?
It tells us T is the number of months after July. So, how many months after July is September?
2.
July is September.
And December is how many months?
6. 5. 5. I had to think.
August, September,
I
October,
I
November,
counted September to December, and I counted 4 because I included both.
Oh.
So I can't really count months.
So we're going to integrate from 2 to 5, and since it's average value,
1/3.
that's when we multiply by 1/5 minus 2, or 1/3. Okay. Antiderivative of 61,
16 minutes.
You're saying one, two.
T.
Oh.
Okay, let's talk about this one. It's going to be a little bit. What is the antiderivative of cosine? Okay, this pi t over 6, that's like pi over 6t. You know when you do the derivative of a trig function, it doesn't change. But the chain rule says you would have to do the derivative of that, which is pi over 6. So we need to multiply by the reciprocal.
6 over pi.
So 18 times 6 over pi would be 108 over pi. Let's use our calculator so we can actually get an answer on this. You can keep the 1/3 in front if you would like. Just plug in your 5, plug in your 2. Make sure you are in radian mode.
I'll use second people.
I don't care.
Nope. Okay. I think I just did my separation.
And then why does it sometimes not open?
Right.
So you're integrating from 1/4 of x negative 1/2 dx. You have to multiply by 1 over the length of the interval, so we'll take it times 1/3 for the average value. So antiderivative of x to the 1/2, if you add 1 to the power, that's 1/2, so 2 goes in front. So you get 2/3, this is like the square root of 4 minus the square root of 1. And we get 2/3. You guys all get that?
Yep. The way you did that differently than I did, and so I was like, wait, what does that make?
I want to add in a quick problem before I do that. So, final example.
Are we gonna do the example 3 that we skipped?
Perfect. Wonderful.
Okay, so you might see this notation. Find the C such that f average, that means the average value of the function, is equal to the average value of f of C. So my function was x to the negative 1/2. Okay, they use C as a variable. It doesn't matter if you use x, it's not a big deal. What do I need this to equal?
2/3.
2/3. So that's like 1 over the square root of C equals 2/3. How would we solve that?
Plus 1/5.
for C equals 3/2, and how do you get rid of the square root?
Square it.
So C is 9/4. Was 9/4 in the original interval for example 6?
Yes.
Yes, it had to be something between 1 and 4 and 9/4. So that's all fine.
Is there any way that sometimes not?
You could get multiple C values and one of them might not be, but there has to be one that is, assuming your function's continuous. Any problems with that? Okay, so here's your huge homework assignment.